Hi Laura, good evening.
Hi there, good evening.
How are you?
I'm good, thank you. How are you?
I'm good, thank you.
I have got the right time and date and stuff, yeah?
I'm sorry.
I have got the right time and date.
Yeah, we are at right place actually and at right time.
Good.
So it's going to be like 1 week. Mostly we can plan for 5 days first, and then based on the progress, we will see like if it is required, we can extend it. As such.
Okay.
Hi Peter, good evening. It's always common in the public platforms when we are delivering these kind of sessions. We need to wait for a while to see people joining. So let's wait for another 3 minutes, 3 to 4 minutes, and then start. I think 6:25 is the ideal time. So where are you from, Laura and Peter? And can you give a bit about whereabouts? Okay, Peter is from London. Hi, Konsari. Hello, how are you? You are on mute, Konsari. Not able to hear you.
Hi. I'm
So,
Taranj from London.
oh, okay, great. So, yeah, I'm just telling that we can wait for another 3 minutes. So 6:25 we can start it. So, in which industry you're working, Konsari?
Sorry, I'm in academia, but I am also, I have a very strange practice which sits between city making, architecture, and public art. So,
Oh, okay.
but I'm also an educator. Yeah.
Genius. Lovely. So, Laura, Peter, Anna, do you prefer to introduce yourself, from which industry you are in, and what are the expectations from this session? Are you beginners, experts? Oh, okay. Sorry, it's from London. Hello, Laura.
Hiya. I about a year ago started teaching myself Python.
Good.
And I now work as a data analyst, but would like to be a data scientist.
Oh, okay, great. So you are working as a data analyst currently. Okay, and want to transform to the data scientist.
Yes.
Okay, great. Anna and Peter?
I'm having a bit of a fight with my camera at the moment.
Should be all
So,
right. If you are not, I mean, if your camera is not working, it's okay. It's fully understandable. Go ahead, please.
I finished a data science intensive bootcamp last month. So I'm now starting to look for jobs as a data scientist. Before I worked in supply chain analytics.
Oh, supply
So
chain analytics, interesting. Interesting. And Peter? I think Peter got some issue with his mic, if I'm not wrong, because he keep posting. That's fine. It's okay, Peter. You can introduce in our later session. So, yeah. So let me introduce myself. Myself, Rajesh Suguru. I'm Chief Executive Officer of Digital Disruption Technologies. We got our startup in UK, Singapore, and in India. Well, of course, I got wide variety of experiences. Since 2005, I was into the technical field. And of course, I was part of like various programs, complex programs across the globe. And my experience is into the capital markets, banks, most of the times playing with the data. And sometimes it's not. Uh, Sometimes I play business analyst role, sometimes a data analyst role, and sometimes whatnot, because industry is expecting various skills to be added. when we are progressing. And of course, we are focusing on the Web 3.0. You might be noticed from our profile. We are closely working with IDS, DRISC, and National Bank of Nigeria on the various initiations of blockchain, including CBDC. And those sessions are going to be in the future. And for now, we can focus on data science. Okay. Great. Let me share my screen. Oh, Anna, you're here. Great. Actually, I prefer to everyone turn on their cameras so that it will be more lively. At least I won't feel that I'm speaking to monitor. Yeah, good, Laura. Thank you. Okay, I think Peter got some issues with his camera and microphone. That's okay. It's good to see one on camera. And this initial session I'm planning for the 5 days. It's continues until Friday at the same time, meaning like 6:20 JP. Okay. And I believe that this is going to be comfortable to all of you. And today's session is going to be very introductory, and who are in the process of a data science journey and transforming their roles from data analyst to the data science roles, or kind of like whoever looking for the machine learning and artificial intelligence roles. So what are they need to do and how they can acquire these skills. And it's basically a roadmap session. So you can just look at various aspects where you need to pick it up. Rather than working hard, we always believe working smart. That's going to help you actually. So we will see, we can obviously, it shouldn't be one-way flow. It should be two-way flow, because you already have some expertise and experience in the data science side. And obviously, I want to hear your experience and what are the challenges that you are facing and how these challenges are addressing in the industry that can be discussed and worked out on. So these are the basic ground rules for the today's session. So I hope everyone is happy with that. Right? Great. Let me share my screen in that case. Mhm. Okay, are you able to see my screen? Can someone say yes or no? Okay,
Yes.
great.
Yes.
Great. I can see thumbs up from, I'm sorry, and thank you. Thank you for confirming. So it's basically like most of the data science roles. And of course, like the way how industry operates is getting the recognized certificates from various certification providers. But I am not big fan of certificates. Usually I go through their experiences and expertise and challenges that they faced when I interview the candidates. And at the same time, it is better to learn the things in a structured way to accelerate or expedite the learning process, rather than just sitting and trying to see and figure out. Because like a simple example, when I started on capital markets, without having any knowledge on the capital markets, but being a complete techie, it took me a while to understand what are the user expectations from me and how I can really get the things work out for them, right? So because as long as if we fail to understand the user's expectations, definitely we know that we failed, because that's why we are working day and night to give whatever the best that user is expecting, right? So learning things in a structured way, learning the things in a user expected way, and learning the things on the market demands is going to be like super important. And this is what I believe. And of course, like here is the topic, certified data science. Though it is saying certified, we are not selling any certifications here. It's just that you should be in a mindset that you are learning the things in a structured way, right? And obviously, though we stated it as machine learning specialist, you can see at the bottom, it is a roadmap to the data scientists, ML, AI roles. And obviously, DL is again integrated animal of AI. So I just placed it as AI here. Okay. So anyway, this is just about our company. It was like when we were in Singapore. So we got like a lot of various social medias that I will post it to you later. Anyway, we can connect there, and we can create like some private group as well there. Let me put it at the bottom. It will be easy for me. Okay. So this is fine. So whoever attend for these sessions, they will be getting some kind of like Google Drive access where you can see the documents that you can use as a handy tool for your day-to-day jobs based on your roles actually. So I think no action is required from you. Okay, now here. Laura, you are interested on the data science, right? You want to transform yourself into the data science role. So what do you think you have to do to transform into the data science role from data analyst?
So my understanding is that as an analyst, you look at data that has already happened. And then for data science, you've got to create models to look at stuff that hasn't happened yet.
Okay,
Future.
great. That's great. Yeah. And Anna, Khonsari and Abhijit, he just joined. So you want to add something here? What are the different data science roles that you can see around you in the industry?
So I see mostly conventional things which are talked about in the media, but I'm sure you have some non-conventional aspects in mind. So, for example, one non-conventional data aspect is digital literature, or what they call digital aesthetics.
Mhm.
So that's one non-conventional role that's possible, isn't it?
Yeah, that's interesting actually. Yeah, of course, the market is keep transforming and the user expectations and product deliveries. So obviously there are a lot of things are changing. Yes, that's interesting one. And anything else, any other roles that we can see regularly and frequently in the industry?
I suppose for me, the interesting thing is that with all these new technologies, how do you create new markets or create new industries rather than just respond? Because, you know, what excites me about blockchain is its subversiveness and disruption in a way, and shift in power. So my worry is that if we always focus on the top-down power, then we just reproduce the same things over and over again. So in a way, maybe it's quite, sorry, I'm not a data scientist, but I do a lot of innovation in what are new industries or future. So in a way, maybe that is the other thing to think about. What is the industry, somehow, rather than feeding into the market.
Yep. Blockchain, obviously, it is transforming the world. And with the latest adoption of CBDC by the central banks, that's become even more important. Of course, the public blockchains, we got a different perception for the different people, whether it is credible or not, because the chains might wiped out at any point in time. And whereas like if central bank issuing the digital currency in the digital form, it's more trustworthy. Yeah, of course, data science, again, it comes into picture even when it is a blockchain and most of the ledger transactions happening in the chain. And there should be a off-chain mechanism that should be in place to validate these transactions, and of course to present it to the different parties in different ways, right? So again, data science is going to play a very important role, and that depends on the volume of the transactions those are going to happen either in blockchain or in the centralized system. So that's going to be like for sure one of the best use case. And Sebastian, you want to add something here?
Hello, no.
Okay, great. And Abhijit and Sebastian, if you can give your quick briefing, it will be helpful to us because we are going to be here for next 5 days.
Sorry, can you say that again? I didn't.
A quick briefing from you might be helpful to others to understand your expectations and your expertise and from which background that you are from.
Yeah, so I have a background in engineering and simulation, as well as management. I am at the moment I'm doing some part-time teaching, which is covering the topics of statistics, operations research, and data science. And also I'm involved in some other academic fields, but this is what is most relevant to data science. And I was looking for new applications as well as how to become at least a part-time employee in a data science field.
Yes, that's good. It's good that you are into academic so that you can understand what's happening in the latest technologies and world. And of course, it should be from the recognized university. Otherwise, so we'll lose the academic world actually. Great.
Mhm.
And Sebastian, any quick thoughts that you would like to share here?
I'm learning Python, and I'm interested in data science. That's all.
Okay. Okay, great, Sebastian. Good to learn from you. So now, yeah. So any industry, when you look at it, the first and foremost and highly preferred role is business analyst role, irrespective of whether it is data science or it is blockchain or ML, AI, or banking. I mean, like if you take the industries wise, banking, supply chain, or any other industry. Because someone who knows the business expectations or user expectations and the market, who can transform that into the technical feasible solutions and making the technical team understanding on what the user is expecting and whether it is feasible with the current technology available or not, is quite important, right? So if we fail to understand user expectations itself, we lost. So irrespective of how the industry transforms, there is a role called business analyst. And that business analyst, if he have data background and data experience, and if he or she, sorry, and if he or she knows how well they can transfer or like they converge the user requirements into the actual technical solutions, the complete project success depends on it. So business analyst role, knowing the data background or having the data background and industry knowledge. For example, if you are working for the banking or capital markets, knowing the capital market knowledge, I mean, having capital market knowledge is always value add, and that's expecting from the business analyst. And at the same time, understanding the volume of the data that we are going to play, the number of deals that it is going to play, I mean, like the flow into the system and how this data going to flow into the back office, middle office, from the front office after we book the deals, and what is the different complex pricing models that we are going to work on, and what are the analysis that we are going to perform, and what sort of market data that we are going to work on. These are the things going to be critical. When I say all these things, it's about the volume and the data flow and the pipeline. Understanding this pipeline is going to be important, right? And the business value, what we are going to derive from this is another critical aspect that the business analyst has to consider. If someone is aspired to be business analyst, you need to understand number one, domain, and number two, the pipeline, and number three, the technical limitations of the tools or techniques that you are working on and the systems that you are playing every day. So having knowledge is important. And then like exploring or becoming expert in that is the second step. Right, data analyst, Laura, you are data analyst. So data analyst usually like they play with the data, meaning they are the experts in looking at the data in various dimensions. So looking at the data at various dimensions is the skill set that it is required to the data analyst. And deriving the meaningful insights from the data that what flows, because most of the times whatever data flows into the system is garbage. It's not garbage when we really look at in a different angle, and if we play with the data and make it more sophisticated to derive sophisticated data to derive meaningful information from it. So data is raw, that's always flows from the customer when they key in the data into the system, and that goes into the system. Once that goes into the system, playing with the data to derive meaningful information based on the with which function that we are working, function of the bank or function of the organization that we are working with. Based on that, pick and choose and make sure that the data is clean and clear to derive the meaningful information from that, which can add value to the business again. So data analyst role is very important, where we always shouldn't look at in a technical perspective, and we need to see why this data is in place and what we are going to derive from this data. So that's going to be, and of course, dealing with the volume again, based on the recent business nature, a hell lot of data used to flow into the systems, right? So that is also going to be important. Yeah, Abhijit, please go ahead.
Yeah, so you have touched upon the volume of the data and who's going to use the data, etc., which is very much, let's say, which is the operational aspect of data. Now, the operational aspect of data depends also, as you already said, on the broad operational aspect of what the organization is doing. But I want to ask you, from the point of view of a data analyst, or from the point of view of a data scientist, what is the connection, if any, to the strategic management, to senior management? Because I have some exposure to management consulting, and I thought that I could also bring in that side of my experience.
Yes, that's a very interesting question, Abhijit. That part I'm going to cover in soon. Basically, like when you go to the third or fourth pointer, you can look at a clear thin line between data scientist role and data analyst role, and how they are going to work with the senior management. So when you look at data analyst, those are like technical expertise. I mean, like those resources have the technical expertise. They look at the data in terms of volume, and in it's like a deriving meaningful insights from the analyst. I mean, like data that they gather is a data scientist role. So data scientist is a bit bigger role, where the pipeline includes collecting the data, analyzing the data, cleaning the data, and deriving meaningful information, developing if they are into the ML, if the industry is into the machine learning, developing sophisticated models that can suitable to the data that they are using, and again predicting if it is a predictability that the industry is working on, predicting the right information to give a proper insights to the senior management. So data scientist role is a bigger spectrum, whereas like data analyst is one of the role who help or like work closely with the business analyst and the data scientist to derive or like to help them in the day in, day out operations, basically. Is that answer your question? Anyway, like while we move forward, we can uncover a clear difference between data scientist and data analytics. What are the skills that those particular roles is required?
Yeah, the difference between data analytics and data scientists will become clear, no doubt. But as you said, later on, you are going to expound on how these roles connect with senior management. So I'm looking forward to that later on.
Exactly. And if you look at the fourth bullet point, I can definitely like, as I've been delivering these kind of sessions since long, I can predict the next question. So data scientist is able to do predictive analysis. And whereas data analyst and data analytics manager has to work closely with the data scientist along with the business analyst to present themselves or like their systems in a better way, or what's the value that it is going to derive to the senior management. So this is all like different functions of the organization where they work with each other closely to bring or to build a value system to the organization. So it's just data is data, like data pumps from various aspects, right? It might be flowing from their private functions, kind of like if it is a bank, their front office system might be keying the deals, and all the deals might be flowing into the system as a raw data. And if it is a core banking, let's say if we fill the loan application, so the loan application, all the data goes and sits into the system, and from there, different teams work on the different areas. Like let's say if you want to predict on kind of like who can churn or who is going to be default on the loans, and kind of they might need different information, different features, and the other teams might require different information as well, right? So based on the requirements, the systems will be obviously hard forked and kind of like divide, and and the information flows into the different bodies based on that. Okay, and then basically like data engineer role. Data engineer is, I think, like Abhijit, you got that expertise, right? The data engineering expertise.
No,
So
what I meant is that I have the experience of being an actual engineer, not data engineer.
data engineer. Okay, okay.
Yeah, so I used to do chemical engineering, and in that I picked up a knowledge of how to do model processes.
Okay. So even in that process, are you going, I mean, like, had you used to play with the data?
Of course, you can't do any simulation without data, right?
Exactly. So feeding the data is a data engineer role, right? So basically,
Wow.
like you might not be specifying yourself or like stating yourself as a data engineer, but in general, in the data science world, collecting the data and feeding the data into the databases is a data engineer role, because there must be like different infrastructure needs and different architectural needs and different data models that the data engineers has to aware. So data engineer is someone who have an expertise.
Another clarification. This issue of data cleaning and data wrangling, is it also part of data engineer?
Yes, it is. It is actually. I mean, like previously it used to be a big data roles. But now if we look at a whole picture, if they are talking about data science in the industry, and if they feel that they are doing something in an innovative wing, then yes, these roles are also part of the data engineer. That's correct. Right. And data architect is someone who knows a complete the big picture of the data, right? So data engineer knows how to fetch the data and feed into the system, whereas data architect is someone who guides the data engineer to how to fetch the data and how to fit that volumes of the data into the infrastructure that is available for them. So data architect is the one who looks at the bigger picture of the different functions or different bodies of the organization. And he knows like what are the different sources of the data available in the market or like using by that particular organization, and how this data flows from the source to the data feeding system. So whereas data engineer sits on ground and looks at the technicalities of it, and then make sure that all the data flows from the source and sitting into our system, right? Which can be accessible later for the processing and used for the deriving various business value. Okay, database administrator, obviously, they are the ones who takes care of the security and the backups, you know, export, import, and make sure that the data integrity happens. And most of the times they interact again closely with the data engineers to see like what sort of information that they have to feed in, and what sort of data that they had to feed in, and what are the different downstreams and upstream systems that they have to work with. The life cycle of data science we are going to discuss in detail soon in the next one. And machine learning researcher, this is the new role if the company is opting for the machine learning. And can someone say like what's the key difference between machine learning and deep learning and artificial intelligence? And okay. Abhijit.
Okay,
Laura.
give it a try, then I can say something. So machine learning actually covers the whole gamut of models that are used by data scientists, whereas deep learning usually indicates those models which are based on neural networks.
Yes, you are to the point actually.
And as far as AI is concerned, it's actually a sort of a misnomer, because now it is being used as a catch-all term, but real artificial intelligence will come when you can use when machines start to understand the meaning of words.
Yeah, it's just not the words. Yeah, I mean like reacting to the situation, something actually like it might be words, it might be text, or it might be anything, like how a human being reacts for various situations based on the environment in which we are acting on.
No, reaction is
So-
already, the reaction aspect is already started, but it's a mechanical reaction. It's not an intelligence-based reaction.
It is intelligent-based reaction in some areas, of course, yes. The maturity levels of the reaction of the systems is not to that level based on the environment, because it's obviously continuous learning. Even human is not perfect until they experience and exposed to the different environments, right? So after all, it's a machine. So you are right, machines are not that matured and as fast as a human being reacts to the situation, and machines are not there yet. I agree. But artificial intelligence system, when you look at in the future, they should act as similar as human being, and in fact better than the human being. That's the future of the artificial intelligence, or expected future of the artificial intelligence. Right. So it's basically like the way how our neuron works. The complete flow has to work in a box which acts on that. For example, you can take in US, in Singapore, they started like driverless cars or driverless vehicle. It operates across the university without any failure so far. And obviously, if you take that into the new roads, it will fail. Whereas the environment in which it's got trained and learning, it's never get failed. And that maturity used to be like adopted over the period of time. And of course, you can see many use cases, even in the US, after adopting like so many cabs, driverless cabs, and it's got into collision at one point in time. And because of the regulatory requirements, it's not so fast moving aspect because it shouldn't cause to the life threatening, right? And whereas if you look at where there is no life threatening issues, for example, robots cleaning the roads, robots doing a lot of the internal stuff, working in the restaurants or working in the offices, working in various zones. These are the areas where it is moving fast, and the maturity of the robotic systems, artificial intelligence systems integrating with the robotic systems is growing fast. It's just not sensor based in recent days. It is about learning the environment and doing reinforcement on that based on the rewards and penalty, and acting next time wisely based on the feedback that it is received from the environment. So this is basically artificial intelligence systems key role. Whereas like ML, if you take it, it is the human being who decides what features are going to helpful for them to derive a meaningful insights from the data that they collected. And obviously there is no correction process available, auto correction process available in the machine learning, and it works purely on the statistics based. That is probability. What is the probability this being happen? I mean, like this might happen in the future by looking at the data that they collected, or like the previous historical information, right? It's just learning from that. And of course, like there are different ways of machine learning that we are going to discuss in soon. Right? And deep learning is something, again, processing based on the functions. It's basically like our neural networks. There are different functions that we inject into the neurons. And then based on the data it collects and train, there are a lot of hidden layers behind the scenes which got different functions operating again. And coming into the conclusion that, yes, if these kind of data that I can see in the future, and these are the meaningful insights that I can derive from that. So that's where like deep diving into the data and deriving more sophisticated information and self-train and easy to train most of the times. That comes with the neural networks based on the situation. Right. And obviously, as you look at it, data engineer is the one who feeds the data, and ML engineer is the role who involves in deploying the models. So where actually, like based on the current situation or current industry practices, these are the places where most of the machine learning models deploy. So like ECL, AWS, Heroku, Docker, and Docker becoming predominantly important because of the beauty that it brought on board, the independence of the operating system that it is operating in and the images that it is carrying, right? And obviously, these need to be like evolve over the period of time, and ML engineers should be in a position to understand how these models, whatever the deployed models, can be stabilized, scalable, and they can effectively respond to the situation. So we have like again the ML model maintenance that we will come across later. I mean, we will go through later. So here is the big picture, Abhijit. Does it make sense? Or like anyone, Anna, Konsari, Laura, Sebastian? Yeah. So
Yeah,
are you able to
sorry.
visualize what we
I'm just
discussed so far?
Sorry, I'm
Right?
just listening. It's not really my field, so I'm just listening to understand. So that's why I'm not saying anything.
Yeah, I mean, like at least this picture, is it visual representation of what we discussed so far? Right. Okay, great.
Yeah.
And then there is nothing much to explain here. So data science role, Laura, as you are aspired to be data scientist, so you must have experience or expertise across these areas. In the sense like you need not to be technically so strong in understanding what are the neural networks, what is CNN, what is RNN, and you need not to be like so strong in the ML. I mean, like the different models, how you can develop kind of like regression, logistic regression, the linear regression, and kind of like ensembling models and so on. But knowing these things helps you when you are in the discussion with the various roles that we spoke just now. Right? Everyone got their own role to play in the industry. It's not that you as a data scientist, you are going to sit whole day and night and has to sort out everything. But working with these functions integratedly is going to be the data scientist role. So data analyst transforming to the data scientist are required an additional knowledge on the industry and having bigger picture on what's happening on the industry level, or like at least to your project or program level, to look at the various aspects and various functions and work with them integratedly. Right. So because data science is across the places, and obviously AI is the system which sits on top of ML and TL. Right. AI is basically like app or any user facing system, which can be used, for any to fulfill any business purpose. And whereas behind the scenes, there might be ML, there might be DL, and there might be reinforcement learning, which is learning like, I mean, there are different mechanics which we can discuss later. And there might be many other technology and technical aspects might be running behind the scenes, but to the user's perspective, the system should think and act like a human. And it should like as an assistant to human being. And sometimes it might act superior to human being if we look at our fancy what it's called Hollywood movies, right? So that might happen as well. I mean, there are high possibilities that happen. Okay, so here are the like very traditional definitions. So basically, like AI, it enables the machine to think and act, and obviously, as I said, like AI should be using underlying ML and TL. Basically, the underlying should be either ML or TL models, based on which, like, of course, like there is a reinforcement learning that happens, like continuously it learns from the environment, and based on the reward and penalize mechanics, it works in a different way, right? So if it learns more than the human being, then it's become superior to human being, and which is not the case at least at this stage. So we should be glad about it. Right. And machine learning, as I said, like it's all about the statistics, probabilities, right? So what is the probability of this event to occur in the future? Like, for example, I work on the market risk very heavily. So what is the value of my portfolio is getting into the risk with 99% confidence level when tomorrow market is open based on the closing rates as of today, meaning like market closes today. And I know by taking that as of today's statistics, today's market rates, and calculates back into the 250 days market movements and apply my position, and then derive what are the chances that there might be like, what is the max loss that I'm going to incur if the market moves that was happening since last 1 year, right? So, and that is again with what probability? Is it 99% confident, 98, 95? It's all again about distributions, right? So again, to become data scientist, having this knowledge is an important aspect, but need not to have like super expertise in this, meaning like need not to spend our age again, because we learned statistics when we were kids, and we need not to go back and again revisit all the things and learn from the basics. What is this? I mean, like, how does these things works? So knowing what is not an important, and knowing how is an important aspect for the data scientist, right? Because we need to understand obviously distributions, and we need to understand probabilities, because this is the terminology that they use. How confident you are that your model is working fine. You should say like my model performance is showing like 98% accurate by looking at the test data that when we pumped it. And we will learn like what is training data set, validation data set, and test data set, and all these aspects. Those are like different components, or like comes into the picture when we discuss about the ML pipeline. How does that works? Right. So basically, like whenever your model look at the unseen data and predict exactly the way how it was happened, at least close to that with some percentage of confidence, that's all involved in the, I mean, like that's all covers as part of the statistics. So just need to understand that it is about the probability, it is about the distributions, it is about the predictability capacity, and this is about AUC, area under curve. There are like different aspects how we measure it. So understanding those concepts is important, but not as a like not exactly the way how it is like when you toss the coin, what happens, what is the probability, and you need not to learn permutations, combinations, and all statistics going back to that actually, right? So understanding the industry use cases is critical. So in that, again, there are two different types. Supervised is again, like most of you might be familiar. When you look at the Gmail, when you get some spam mail, you just click on the spam, then it label it as these kind of wordings or this kind of header that it comes with. There is a different logic behind that the Google uses, why it's marked as a spam, right? So based on that, it performs some analytics in the future. If it's a similar set of wording mail, if it shoot up to some other client, that consider it as this, it might be again, it's a probability, as it is a machine learning model behind the scenes. It might be of, I'm confident that this mail is spam based on whatever the learning and features that we used and the models that we are, they are in place, and then that it moves to the spam, right? And obviously because so many users marked it as a spam, so it is labeled, easy to identify. Right? Any other examples that you would like to add? Because I took Gmail because it's very easy. And there are several, yeah, go ahead, please, Anna.
Plenty of examples, like predicting prices, as long as you already have the past price of something, you got a label, you can do it.
Exactly. Predicting future prices. Let's say it is real estate. So if you have like all the, we can say prediction comes into picture. I mean, it's not like labeling or kind of classifying, but at the end, it is again regression, where we are in the process of like predicting the future values. So the labeling comes into picture when it is classification most of the time. So whether it is yes or no kind of. And of course, there is multi-classification that we can perform as well. And when it comes to the regression, it is by consolidatedly looking at the movements, or as you said, like movements of the housing prices since last 1 year or 2 years, predicting the future value comes into picture there actually. So that is regression method. And whereas like logistic or kind of like classification, when we look at it, it is based on the past label, say yes or no confidently, right? Yeah. So unsupervised, any examples that you can take? Anyone? Abhijit, Khonsari, Laura. What is unsupervised? Basically, here we are supervising spam or not spam, or like some credit card holder, whether they can default or won't default based on like previous experience. Okay. Yeah. Yeah, Abhijit, please
So
go ahead.
again, unsupervised data can also be this thing for clustering. Clustering is one you have mentioned. The other is making recommendations to clients like they do in Amazon.
Okay. Great example.
Sorry, come again.
Great example, Abhijit.
Thanks.
It's a great example. Yes. Unclustering, basically like, yeah, recommendation systems works on the clustering based on the unsupervised learning models. Laura?
So unsupervised is when you don't know the label of fields, you don't, and the model comes up with clusters, or you can use different models to kind of group them together, and then it kind of, you can see relationship based on the grouping.
Yeah, that's correct. So in the Amazon's case, where we use supervised, where we used unsupervised? In what, let's say like the recommendation system, like simple recommendation system, right? You are in the process of developing the recommendation system and you got two options. One is supervised and one is unsupervised. In the Amazon's case, where you use supervised, where you use unsupervised.
So unsupervised will be to find out which clients are similar to which other clients.
Yeah, Vijit, go ahead, please.
And supervised, I can't recall right now at the top of my head, but yes, I think there is a role for supervised thing as well. It's just that the supervised, this thing is not the challenge. The challenge is the unsupervised part of it.
Yeah, of course, like every model, it's got its own challenges. Yes, the complexity wise, unsupervised is complex. And in the Amazon's case, when they make recommendation system, let's say Raja Suguru, by this identity in the future, in the past, when I buy iPhone 6, and I bought at the same time the case associated to that and charging systems associated to that, and many other individual components, right? So if I bought this, that is labeled for my ID. So in the future, if I upgrade from iPhone 6 to iPhone 7, iPhone 7 to iPhone 8, iPhone X version, then the recommendation system, the model behind the scenes, it knows that I might be interested on the other individual components as well. So that presents in that way. And obviously, when it comes to unsupervised, if the system doesn't have any data about me, so the model behind the scenes clusters, meaning like whoever bought the iPhone 5, what's the best that they bought, or like what are the add-ons that they bought as part of this process. Based on that, the recommendations of the add-ons comes into picture. Like, yes, he bought iPhone 5, and then the recommendation is you might be looking for based on the various others users bought it. So it's a cluster of the iPhone 5 where iPhone 5 users who bought these additionals, right? Presenting that goes into a clustering. So of course, like if you take the banking system, marketing system, so clustering is very important to understand to promote what sort of offers to what sort of users, right? Let's say if there are the user category where they are highly focused on the home based or like groceries. So promoting to them kind of like the super luxury cars might not add any value. So clustering these kind of customers who are interested on the groceries and pump the marketing flyers accordingly, or like make sure that your add-ons pop up accordingly, that adds value to the business. And again, identifying the cluster of users who got this kind of mindset, who can invest on the luxury cars and luxury goods, presenting to them the luxury goods is an important market aspect. So that's where clustering plays an important role. And whereas this supervised learning, it's very individual specific, and which was labeled in the past. Based on that, you might be interested on this as you are upgrading to the latest version. So presenting to the individual, and obviously like there are several use cases. This is one of the use case of that. And spam and spam default or not going to default, going to buy or not going to buy, yes or no, everything comes into picture when there is like when there is a label data. So label data easy to handle with. Clustering, it's based on the behavior of the users and based on the nature of the data that we have, based on various aspects or expertise of the business analyst and the technical team and all the roles what we discussed. So there are a lot of factors involved in that. So that's a bit challenging, as Abhijit said already. Right? And reinforcement. This had you heard this word?
Before we go to reinforcement, I just remembered a specific application of supervised learning in Amazon-like situation. So as you said, if the client is new, one way to make recommendations is what you said, based on what he's just bought. But the other kind of thing which is also done is to look at the attributes of this new person and calculate which group he is close to.
It is clustering.
And make a recommendation based on his other characteristics.
That is clustering, basically. Taking him into the different group, like taking him into consideration of specific group and making recommendations is the clustering. That is unsupervised. Supervised is based on his specific
sometimes
behavior
this clustering
and
is
label
based
data.
on past purchase data, and sometimes it's based on attributes which have nothing to do with purchasing directly. Is that right?
Yeah, of course, like it's mix and use. We can always, that's again specific to the use case. We cannot definitely say this is only right or this is wrong or kind of. And usually the way how this marketing, end-to-end marketing pipeline works is, it's look for the individual behavior, and then it moves to the second level. If individual behavior is not available in the system, then it looks for like to under which category or under which cluster this particular customer can come into. And based on that, it makes the recommendations. And if that clustering also fails, I mean, that's the first opportunity that the Amazon gets to learn about the user. Sometimes it doesn't mean that everyone who bought iPhone X version going to buy all the recommendations, right? So that's where it's going to label, yes, we recommended this, and these are not opted by this particular customer, and his behavior is a bit different. And next time when we log in, the recommendations will change and customize to specific user. And that's again labeling. So to get an opportunity of labeling on the customer behavior, we need to identify under which cluster, I mean, at least close to the reality, under which cluster this particular customer can come into. And then obviously we can, over the period of time, the time always passes. So over the period of time, we can always see what's the exact or closest recommendations that we can make. Of course, it's a system, and the models fine tune accordingly and presents or like makes the recommendations accordingly. So it's always mix and use. We cannot say like, yes, this is right or this is wrong, or you have to stick to only this. And of course, these process and methodologies and the technicalities and technology always evolves. And that makes process even more easier to understand the customer's prospect actually. Okay. Abhijit, is that good? Can we move to reinforcement learning? Yeah. So reinforcement, I need someone to say like, yes. Had you heard this word in this session? Just now we used this word, right? Reinforcement. Where do this applicable? Okay, no problem. So reinforcement is basically learning from the environment and then making some corrections to the model. Meaning like, let's say if you look at, I'm not sure in London, but at least in Singapore, we have like robots cleaning the payments, basically the pathways. So the first time when we install the robot, it have very basic and bare minimal model deployed into that, and a camera attached to that. And every time when robots make a move, it identifies whether it is correct, meaning whether it is rewarded or it is penalized. And based on that, the model evolves over the period of time. So this is called reinforcement learning. In a generic terms, when you show to the kid like first time tomato, right? So kid identifies it as okay, red, round, and whatever some specs that they form in their brain. And next time when they see apple, they say it's a tomato, right? We won't reward for that as a parent, and we say like, no, it is not tomato, it is apple. And based on that, they correct their model. And next time when they see tomato and apple together, they know clearly how to distinguish these two. And in a similar way, the reinforcement learning is something very close to the making or replicating a human being. Meaning like it's just cloning the human who can learn the environment and act based on the situation around, basically. Okay, so reinforcement learning is very important. And of course, all the self-driving cars, that's where reinforcement learning is the technique that they use. And behind the scenes, it requires a lot of infrastructure. It's not so easy as we are talking in the slides. It's not as easy as even machine learning and deep learning. Deep learning is a bit complex, and whereas like if you look at reinforcement learning, it's even complex. So it is supervised, semi-supervised, where it learns from the environment based on the rewards it labels, and based on the penalties, it labels like, yeah, this is the action that I shouldn't take, and this is the action that I should take. Right? That's why we can say it is supervised, but not supervised. Again, our kids example is the best example, right? So next time when they look at it, they know what to correct about it. Okay. And then deep learning, as Abhijit rightly said, it's all about the neural networks. And we can see like different neural networks here. One is artificial neural network, convolutional neural network, and recurrent neural network. What is the key difference here? And obviously it's there in the slides. So when you are present, when your data is present in the numbers, then you use artificial neural networks. And convolutional neural networks, that's when you are collecting the images. For example, NASA is best example. So NASA collects a lot of images of the weather, and predicting the weather conditions or predicting on the various geographic locations, how does it is and how difficult, how easy, and kind of all these analysis you can perform on the images that's collected by the satellites, or I mean, like obviously by NASA. Right. So here there is something called transfer learning. Again, like it is a short-term memory, long-term memory, and kind of a lot of concepts comes into picture that we will learn in the future. And obviously, the recurrent neural network, it is very well known or like applicable when there is a time series data, such as like seasonal data. Kind of like March to May, there might be like huge business, and from May onwards, there might be like less business for electricity, and kind of for certain commodities, what is the demand in which months, and kind of. So all these things can be learned by using the RNN. Okay, so data science again, Vijit, this is what that I'm going to say to you. So he or she should have idea on statistics, probability, and linear algebra, because they are the one who is going to work with all the functions, and they are the ones who is going to derive the value from the data that they are playing with. Rest of the roles, they just like, for example, data engineer, they know like they have to pump the data and place it in the database or like in the storage area. That's it, their role is done. And business analysts, they have to collect the data and then make sure that they translate into the technical possibilities and feasible solutions done. Data architect, they know that they have to just make sure that have to have a bigger look or like the big picture of the complete project or program, and make sure that all the functions downstreams and upstreams and our centralized system is working hand to hand. And making some recommendations based on that to the different functions, again, like data engineer and kind of like other bodies. So ML engineer, they know that they have to deploy the models, and they should identify what is the best infrastructure available and where we can deploy to make sure that the customer get like high satisfaction, right? Or like easy to access by the customer, and high availability always keeps in mind. And that's where like ML role comes into picture. Whereas data science is something beyond that, where they have to understand exactly whether this model is performing well or not, and whether all these functions, what sort of data need to collect, and what sort of data need to pump, what sort of data need to store. and what are the meaningful information that need to be derived, and what are the user expectations from this data, and how clean or how better to use this data, and what are the different logic or like different statistics method that need to be applied on this data to derive expected function from that or expected value from that. Actually. Right? Any questions here? All good? Okay, great. I can see thumbs up from Anna. Laura, no questions. Any questions here? Konsani, Abhijit, and Sebastian.
No,
All
all
good?
good. Thank you. Just listening.
Okay, great.
So yeah, I have a question. You outlined the 3 different kinds of networks. Obviously, the more complicated ones are CNN and RNN. In your opinion, if one is trying to analyze patterns in literature, which would be more suitable, CNN or RNN?
RNN. Because CNN deals only with the images. Let's say if you are analyzing the images patterns, then you can include CNN. If you are playing with the data, which is numbers basically, right? So then, numbers or text. So when you are doing text, RNN integrated with NLP is going to be greatly helpful to you. If it is a text, as you said, research, it is a text. Text analysis can be performed better by using NLP. That is natural language processing.
But when you feed in the images as numbers, there is a sequence to those numbers, isn't it?
Sequence to those numbers means, sorry?
In the sense that if you fed the data of the picture upside down or sideways, would the computer not produce different results?
Yeah, obviously all the pictures has to convert into the zeros and ones, and and they cannot read as a pictures at the end actually. So behind the scenes, it's always the numbers that matters. It's a complex matrix that generates based on the picture that you are pumping into the CNN. CNN deals with the picture doesn't mean that it reads the pictures. It's obviously it takes as an input, and CNN got the functions to convert into the complex matrix where it understands each and every pixel. And then at the output gate, it knows what it has to perform. Again, there are some complex functions in place to generate these kind of the complex matrices and to analyze.
So you don't need to get into the detail now. You don't need to get into the detail now. You've answered the query I had for the time being.
Great, Abhijit.
Can I just ask something? So for example, with things like DALL-E or Midjourney, they use CNN, do they then?
Which one? Sorry, DALL-E, is it?
Yeah, so it's an image generating AI.
Yes, they should be using CNN. Without, so far there is no hack other than CNN for image processing. That's the best solution that should be in place. For example, like the Kiddie Palace or any kid-specific dolls, right? If they have to make some recommendations, there are 2 ways. There is a label associated to each image, and they can label and make recommendations based on the kids' purchase behavior. And the second one, they might be like even doing some analytics on the images that they are presenting to the user, meaning like sometimes the conversion rate need not to be directly based on the label and the way how they look at in the system. Sometimes some kids, they might excite by looking at pink and by looking at blue, by looking at various aspects of the images, right? So to present these kind of images, what sort of images are converting more for the given product, they have to do CNN analysis.
Okay, thank you.
No worries. Okay, I think we already overshot it for 5 minutes. That should be fine. I can quickly, we are going to continue this journey for next 5 days and at the same time 6:20. So I don't want to like again take your time, and of course I need to respect the time box as well. So far, how do you feel about it? Then we can definitely look at on the various aspects of step-by-step transformation, how you can move towards the data science, what exactly that you need to learn in the technology wise and technical wise, and what's the easiest way, how to learn in a smart way than looking at in a hard way, rather than like spending all our time, like 1 year of time on the statistics. And when we enter into the industry, whereas there is a sophisticated library which is doing our job, whereas we just looking at those library functions and saying yes or no, yes or no. We need to see like the way, what value addition that our efforts is going to place, right? So learning as a system is an important aspect as per me. And obviously we need that experts who can judge or justify whether this library is functioning as it is stated or not. That's a different story, but those kind of roles are very limited.
So you said that we are going to continue discussing for the next 4 days.
Exactly.
It seems that I may have some other commitments at this time. So would it be possible to get a recording every day?
Yes, whoever enroll for this or like at least give an RSVP, they might be receiving recording. Yes.
Okay, I did do a RSVP, so you should be having my email address.
Yeah, I will have a look at it. And yeah,
Mhm.
the recordings is available, but we highly recommend everyone to be part of this discussion so that like it will be more lively than, like if it is only technical information, you can get better than this information anywhere in the online. So I'm sure about it actually, meaning like just learning kind of, right? So
Mm.
yeah, obviously if your time permits, I definitely expect you to be part of this discussion, and obviously I have to respect your commitments. And yeah, we will try to publish or like share the recordings to you in case if your time won't permit.
Okay, so I look forward to seeing you tomorrow then.
Yeah, sure, Abhijit. I mean, obviously, the higher you can prioritize, you can give high priority to your commitments, and I'm happy to provide the recordings to you, just in case
But
if you
this
are.
does come as a surprise to other students and me that this is a multi-event thing. At the most we thought it'd be once a week, not 5 days a week. But still, if that's the way you want to go, that's fine.
Yeah, I can. Anna, Laura, Konsari, and Sebastian. What's your preference? Is that daily or weekly? We can go with that actually. Like
Weekly would be better for me because I think 5 days is, I can only do Wednesday and Thursday this week.
Wednesday and Thursday. That's Konsari. Okay. And Abhijit, you are saying weekly once is better for you as well, right?
Yeah, this week, luckily, I may be able to do 3 or 4 out of 5 days, but not every week. That's why if you say that you're going to do once a week, then everybody can plan ahead and keep that slot free.
Yeah, sure. 2 votes. And how about you, Laura, Anna, Sebastian?
Yeah, so I'm not able to do the rest of the week, and then each week I work different shifts, so I'm not be able to plan ahead. I do apologize, but thank you so much for your time today.
Okay, great. And Sebastian, so you prefer weekly or daily, Laura? I don't understand it. Okay, Sebastian.
I also prefer weekly, but don't mind me. Whatever you decide, it's okay. Maybe this week I will be able to join maybe 3 out of 5. I don't know.
Okay,
But
Anna?
weekly,
Yeah, Sebastian considered it. I think like we already like almost everyone is moving towards weekly. So yeah, then what we can do is we can keep it every Monday if that works for you, for a few. And Laura, anyway, she can look at on the and she can always like RSVP. Is that works for you? And obviously there might be few
Monday works.
additional participants. Sorry, Konsari.
Sorry, Monday works for me. Yeah,
Okay.
same time. That's good.
Abhijit, Anna, Sebastian.
Yeah, Monday week works for me. At this time, Monday works for me. Fine.
Okay, great. And Sebastian, he said like he is flexible. That's
Yeah,
great.
Monday it's okay from here.
Thank you, Sebastian. And Anna? Okay. No worries. I think like she might have some difficulties. Then in that case, we can make it weekly, once in weekly. So see you on next Monday at same time, 6:20. Is that all good?
Thank you so much. Thank you so much.
Yes,
Thank
thank you. See you
Thank you.
next Monday.
See you next Monday. See you all. Bye.
Bye.